Documenting how our application works and showing what our API expects and returns is a vital part of most application documentations. This is especially true if you are exposing an external software developer kit or SDK. One great tool to automate this entire process is Swagger. In these next lessons, we'll be looking at how we can integrate and automatically generate OpenAPI documentation for our Nest.js applications. We'll be taking advantage of all the latest tools and Nest plugins to help automate and simplify every aspect of the process. Let's jump right in. One of the best ways to document our application is to use the OpenAPI specification. The OpenAPI specification is a language-agnostic definition format used to describe RESTful APIs. An OpenAPI document allows us to describe our entire API, including available operations or endpoints, operation parameters, input and output for each operation, authentication methods, contact information, license, terms of use, and other information, and much more. Nest provides a dedicated module which allows us to generate such an OpenAPI document simply by leveraging decorators. To get this module installed in our application, let's first make sure we have the necessary dependencies installed. We'll be installing Swagger UI Express since our application is using the default platform Express. Just know that if you've switched your Nest application to use Fastify, install Fastify-Swagger instead. We'll continue ahead as we already have these packages installed, but if you're following along, just pause the video and come back when it's finished. Once Nest.js Swagger and our application's relevant Swagger installation is complete, let's open up our main.ts file and start setting up Swagger by generating a base document, which will be the base object where our API document is contained. Document Builder from the Nest.js Swagger package helps us structure a base document that conforms to the OpenAPI specification. It provides several methods that allow us to set such properties such as title, description, version, etc. Next, let's use these options to create the full document with all HTTP routes defined. Let's start by importing Swagger module from nest.js/swagger and call the create document method, passing in our application instance and the Swagger options object we just created. Now that we've created a document, we can call the Swagger module.setup method to wire everything together. This method accepts a few parameters, including the route path to mount the Swagger UI to, our application instance, and lastly, the document object we just instantiated above. With all of this in place, we can now run our application to see if everything worked. Once the application finishes building and it's up and running, let's open up our browsers and navigate to localhost 3000/API. This is the route path that we put in the first parameter of our Swagger setup. And look, there we have it. We should see the Swagger UI. As we can see, the Swagger module automatically reflects all of our endpoints, and we can see them all listed here. But it seems like a lot of information about each endpoint is missing. Let's take a look at how we can fix that in the next few lessons. If we look at the Swagger UI and toggle, for example, the Create Post Endpoint tab, we'll notice that there's no information on what request body is expecting to properly create a new coffee resource. How do we know what shape of an object is expected by this specific post action in order to successfully add a new coffee if we don't have any information provided to us here in the Swagger UI? If we look at our application's code, we actually have a dedicated DTO class that represents the input API for this endpoint. But unfortunately, this is not enough to automatically generate the OpenAPI schemas out of the box. TypeScript's metadata reflection system has several limitations which make it impossible to, for instance, determine what properties a class consists of, or recognize whether a given property is optional or required. However, some of these constraints can be addressed at compilation time. Nest provides a plugin that enhances the TypeScript compilation process to reduce the amount of boilerplate code we'd be required to create in order to tackle this problem. Note that this plugin is opt-in. If you prefer, You can declare all of the Swagger decorators manually or add specific decorators wherever you need to override the base functionality provided by the plugin. To enable this new Swagger CLI plugin, simply open up the Nest CLI JSON file and add the following compiler options configuration. You can see we're including the Nest.js Swagger plugin in the plugins array here. Let's save our changes and fire up the terminal. To make sure that the Swagger plugin is properly loaded by the compiler, let's terminate the current process and rerun the build in development mode with npm run start:dev. Once the application is ready, let's head back to the browser window and refresh the Swagger UI page. Now, we can see that the UI actually reflects the Create Coffee DTO with all of its properties. The Nest.js Swagger plugin was able to do all of the heavy lifting for us, determining all of the properties here at compilation time. We didn't have to lift a finger. Next, let's toggle the patch endpoint and see if it properly reflects the Update Coffee DTO. It looks like Swagger wasn't able to reflect this DTO properly, and for some reason, as we can see, there are no properties specified here in the schema. To fix this, let's head over to the Update Coffee DTO file and make sure we're importing partial type from the Nest.js Swagger package instead of the Nest.js mapped types package. This change helps achieve the same functionality while instructing Swagger that these are all in fact optional properties. Let's save our changes, switch back to the browser, and refresh the page. Great, there we have it. Every property is now marked as optional, as it should be. As we can see, the Nest.js Swagger plugin not only helped us tackle tough issues, but it even figured out almost everything about our endpoints. Without the plugin, we would have had to put decorators on top of everything and specified every piece of information about each item. The Swagger plugin automates all of this, but still gives us the ability to override any little thing we want if we need to. Our DTO classes are now automatically reflected in the OpenAPI document. Every DTO class has its own corresponding data model or schema. To make these models even more self-descriptive, let's define example values and add descriptions to some of their attributes. Let's open the Create Coffee DTO and annotate all the properties with a new decorator, the API Property Decorator, making sure to import it from Nest.js Swagger package. This decorator allows us to set various schema object properties like default, which sets a default value, description, and many more. Let's add some descriptions to all of the properties here for Swagger to display. Obviously, our properties here are pretty self-explanatory, but it's important to know that you can apply additional information that Swagger can utilize on top of what the Nest.js Swagger plugin already figures out. Now that we have some example descriptions populated, let's make sure to save our changes and navigate to the Swagger UI again. If we refresh the page and click that Post Coffees tab again, we can see all those descriptions and examples we added are now populated on the screen. The OpenAPI specification allows us to specify responses for all of our operations. A response is defined by its HTTP status code and the data returned in the response body. The CLI plugin we enabled in previous lessons can automatically define a single successful response for each operation based on the metadata. It achieves this by inferring the return types from our methods. The Nest.js Swagger plugin is able to extract this type information and automatically add the appropriate metadata for us. But what if we want to define other example responses? Let's say we want to let users know what an API returns in the case of an error. Let's introduce a new Nest Swagger decorator to help us tackle this, the API Response Decorator. The API Response Decorator allows us to explicitly specify additional responses. If we switch to VS Code, let's add the API Response Decorator on top of our findAll method to add additional information to show what someone can expect if a 403 error occurs on this endpoint. For better readability, there are also shorthand decorators available to us for all of the common API response status codes. Let's replace our code to use the API forbidden response decorator here, which lets us remove the status 403 key value as well, as it's already implied. Let's save our changes, head back to our browser, and refresh the page. Let's toggle that Get/Coffees tab, and under the Responses section, we can see that we not only have the Success 200 response we already saw, but we can see our new 403 Forbidden Response section and description. So what we covered in this lesson may not have been very useful in our exact use case here, but it's most important that you can see we have full control over Swagger and how documenting different API responses can be beneficial in many circumstances. Swagger has many great features and additional ways to document our code. A very useful one is known as tags. With tags, we can group and organize related sets of endpoints together. Tags allow us to break down our resources into logical bounded context, making it much easier to navigate through Swagger UI. Let's take a look at how we can group all the /coffee related endpoints into one dedicated coffees tag. To get started, let's open the coffees controller file and simply annotate the coffees controller class with the API tags decorator from Nest.js Swagger, passing in the string of coffees inside. Let's save our changes, open up our browser, and refresh the Swagger UI page. We should now see that all the coffees endpoints are grouped together under a single coffees tag. Note that you can also group endpoints individually by applying the API tags on a method level if needed.